Dr. Barrie Tan is extremely excited about vitamin E. I wasn't sure what to expect in a conversation with the world's leading expert on vitamin E, but I gotta tell you, he got me excited about it too. This was actually super fun because it's such a granular and specific health topic. And deep down inside, all of us health nuts that get into health coaching love to learn about very specific things. You'll walk away being more excited about vitamin E than you ever thought possible. Hi, I'm Erin Power.
And I'm Laura Rupsis.
We're certified health coaches, and this is Health Coach Radio.
This podcast is about the art, science, and business of health coaching.
We share our insider tips to help you become a better coach and entrepreneur.
And we interview expert guests to discover how they've made it in this growing field.
It's time for health coaches to make an impact.
It's time for Health Coach Radio.
Hello, Dr. Tan. How are you today?
I am well. Great to be with you too for this interview.
Yeah, so it's not every day we get a researcher that can kind of take us down a little bit of this geeky path on understanding how certain micronutrients impact the body. And so you have a very unique story. I don't want to steal your thunder. Would you give us maybe a little bit of a 5-minute backstory on your background and kind of who you are?
Yeah, okay. I'm ethnically Chinese. My parents came from China during World War II, and they immigrated and live in Malaysia. So I was born and raised in Malaysia. I know Canada has more Malaysian, not typically in the US, because US is not a British Commonwealth country. And I went to school in New Zealand, another British Commonwealth, and then now I live in the States after I got a job at the University of Massachusetts, first teaching chemistry and later in food science and nutrition. But however, for the last 25 years or so, I've worked in industry, mostly doing research to find out. In other words, if I discover something good, I must be able to extract them out. Otherwise, it cannot be a deliverable usefulness to other people. So not just the discovery part, but they're able to make it so that people can use it. So almost all my research are plant-based. They're based on plant in my discovery. So how did I discover this vitamin E and how did I get into this? Many years ago, it began in 1983. So you can figure out how long that was. I discovered a certain kind of vitamin E in palm oil, and it's not the common tocopherol, but it's a less common tocotrienol. And then I discovered it from rice bran also, like that. But typically from these two sources, you have about 25 to 50% is tocopherol. So I did some work, good, but no cigar. So then my first love in chemistry was in carotene. Carotene would be the colors of like beta carotene in carrot, lycopene in tomato, zeaxanthin, lutein in many plant sources like that for the macular light. The year was 1994. There was a famous ophthalmologist, Johanna Seddon. Professor Seddon at Harvard Medical School discovered that in the back of the retina of the eye, where the fovea here, when the lights come in, she found out that right in the highest pixelation is zeaxanthin, and as it flanks out in the retina, there are lots of lutein, and this lutein filters out the blue light. Now you fast forward today. Oh, of course, we all know this is for macular degeneration, but this is 1994. People did not know that, and it wasn't a long time ago. Then I decided that, wow, I know of a place in South America that this is really a story of, if there were to be such a thing called blind love, this would be it. I'm Chinese, you know. I cannot speak a word of Spanish. I went to South America to look for lutein and zeaxanthin. This is a younger me. I found a giant marigold like that when I was in Peru, like that. Then fate has it. Remember the intention way I went there for.
Mm-hmm.
Fate has it about 30 feet away from me. I found another plant, and that plant is Annatto. This is a beautiful Annatto plant. We call it the lipstick plant. If you go to a botanical garden, you probably find it. And then it stains your finger. We use it for coloring meat, cheeses, like that. And I found this plant, but this color is also a carotene. Remember, I was scientifically a carotene expert, and carotene is very unstable. So I realized that, wow, most carotene in life are not just loosely. They're bound to something like that. If you cook carrot, you have to cook it in oil for a while before the color comes out like that. Or even if it's in lobster, you have to cook it and they deproteinate, and then you see the brilliant color. But this one here is not. So I was surmising there got to be an antioxidant powerful enough to maintain the color. I was expecting, truth be told, that it would be a polyphenol because there are many polyphenolics, a lot more than anything else, but it wasn't. Then more surprisingly, it was a vitamin E. And most surprisingly, it only contained tocotrienol. So I was stuck right back into tocotrienol research like that, even though I did find the lutein and zeaxanthin, thanks to perhaps Professor Seedon that discovered it. But today, people can get lutein and zeaxanthin easily from many sources. So I'm grateful and thankful I persisted on this Annatto and continue research work on tocotrienol to this day. It's 25 years ago.
Wow. That's quite a journey. That's so interesting. You describe yourself as a carotene expert.
Yeah.
And it's like you go around the world chasing after orange things, like marigold.
Yes.
I love that.
Yeah, and you know, right now we are in the fall foliage, right? I don't know, same way are you also. So all the beautiful color is masked by the chlorophyll. So hormonally, the tree is going to shut down. So it's going to close down the chlorophyll, so the leaf would die. And then just before that, for 2 weeks of glory, all the carotene shows up. So the carotene is always there. It's just masked by the chlorophyll green. Isn't that wonderful? So I think about this thing all the time. You know, I maybe I shouldn't say this. I think that if I would be a woman, I would tend to think about this thing. But because I love carotene, it's my passion of my life, I think about this all the time. How this is another time. I know time won't permit. Another time, if you were to ask me, why does a woman's corpus luteum is loaded with lutein? You should ask me sometime. I'll tell you this. That is only peculiar to women, not to men. Not found in any like that. But only in the it have to do with bringing the fetus to full term.
Gotcha.
Oh, interesting.
I know it's another time.
I think it's spoken like a true carotene expert, though, describing like the leaves are supposed to be orange. They're just masked by chlorophyll most of the year. I love it. Okay, so when we're gearing up for this conversation, we're looking at Dr. Barrie Tan. We see, okay, Dr. Tan is a vitamin E expert, but specifically, you discovered tocotrienol. Is that correct? Like you discovered this
in the various plant sources. The compound is known, but people know about tocopherol.
Oh, yes.
Like that. But tocotrienol, where do you find them? Nobody knows where to find them. So if you ever go to a store and look for tocotrienol, you can only find them in 3 sources: in palm, rice, and annatto. And annatto is head and shoulder better than palm. So first, if you ever were to your people were to look for things, first, when they say vitamin E, make sure it's not tocopherol. 90% of all the supplement vitamin E are tocopherol, not those. Of the 10% is tocotrienol, look closer. That is not palm and not rice, but for annatto. And why? Because it's completely free of tocopherol. Only contain the 2 vitamin E that is most potent. And I know you're going to ask me, why are they most potent? But right now, at least when you look at the bottle, make sure you look at the right thing.
I'm going to ask you that, but I want to actually ask you an even more entry-level question, which is, what is vitamin E and why is it even important? Yes. So like before we get into the store and start picking up our tocotrienol versus tocopherol, can we talk about vitamin E broadly?
Yes. Yeah.
Okay.
Broadly, vitamin E originally was ascribed to a compound called alpha tocopherol, the most common one that you find out there. It was discovered by 2 scientists and pediatricians at UC Berkeley, 1922, exactly 100 years ago. These 2 pediatricians, when they gave the animal a pregnant rat vitamin E, at the time they didn't know it was vitamin E. They just removed something and then they are unable to see the fetus to full term. When they gave it, they're able to get to full term. So the shorthand is it became a vitamin E, alpha tocopherol, because it's able to support the fetus to full term like that. That's it.
Okay.
That was it. So, and because of that, it became a vitamin E. However, very shortly after that, people found out that this tocopherol and later tocotrienol, they are very powerful antioxidant. So today, most people know vitamin E as powerful antioxidant. They do not. It will be amazing if they remember it. If it were to be a vitamin E for women, then why am I taking it? So it's clearly not for bringing the fetus to full term, but that was how it became known as a vitamin like that, and probably because the placenta is so large initially compared to the fetus, that's a lot of oxidation happening. And you want the oxidation to happen for the benefit of the baby carrying. But you don't want any bad oxygen to go owie. So therefore you need the vitamin E to protect. So these two pediatricians found out, that is what the vitamin E is there for. So if you didn't have that, then you'll just peroxidize and therefore the fetus cannot carry to full term. So that's basically the behind the original understanding.
Okay.
Got it. So do you find, so here's what I would love to know, just broadly speaking, are humans today finding themselves in a need to supplement with vitamin E, generally speaking, in terms of how people eat? Is it not in our diet? So I guess my question is there such a thing as like a vitamin E deficiency and people need to supplement? Or are you suggesting perhaps it's, we see it in multivitamins all the time, but what specific purpose might someone look to supplement with vitamin E generally? And then I want, if you don't mind, explain the difference between those other two types of vitamin E, but vitamin E broadly. First.
Yeah, generally, there's subchronic condition people have, and one of the easiest way to find out is when people have patchy, scratchy, and very dry skin. Mm-hmm. It will be, and hence vitamin E is used in a lot of dermatological cream lotion like that. Mm-hmm. But that would be an easy because it is right on the eyes, you can see it, but that's only skin deep. If it is something inside your body, you can't see. And those manifestation is not open to the eye. I would say this. If you eat an American diet, it's another way of answering your question. American diet, typically you may get about 10 to 15 milligram of vitamin E as in alpha tocopherol. If a person eat healthy, and then don't ask me to explain what healthy is, but let's say they eat a healthy diet, usually vitamin E you can get from vegetable oil. Like that. Mm-hmm. So you got to eat oil and fat, which we try to reduce. So as you reduce that, then it's less on this like that. And also the elderly in nursing home, because they can't eat meat. And if they cannot eat meat, they cannot get the fat. They will choke. So they eat small pieces like that. And so they would also tend to be deficient in vitamin E. Now, that's vitamin E as in tocopherol. Vitamin E as in tocotrienol, which I know you're going to ask me to explain later, I think that we would even have less. We'll probably have 2 to 3, perhaps 5 milligram at most, unless that person is consuming vegetable oil as in palm oil. We usually skirt away from palm oil because it's saturated fat. Rice bran oil is good. It's a well-hidden secret that people eat Japanese tempura because they fry them in a rice bran oil. That is generally good. If you were to be in South America, having a lot of annatto because they pound them in tortilla chip, this, that, and another thing, then you will get a lot more tocotrienol, perhaps 10 to 15 milligram tocotrienol. Still not enough. What I consider minimum of vitamin E tocotrienol would be about 100 milligram. Now, you ask me why. I'll tell you why. Here, I'll take one step back. In each human body, we have 38 trillion cells. That's a very big number. 38 trillion cells, about 5,000 times the population of the Earth. Let's say the cell look like this mouse here, look like a kidney bean or something like that. Mm-hmm. And then the muscle cell doesn't look like that, but most other cells in the body do look like that, or nerve cell don't look like that. But all cell must have cell wall. Okay. Because they are a gated community. Inside the cell is the nucleus that protect the integrity of the cell, what it's making, like that. So it make you look like the way your parent gave birth to you. And for me, my parent, that's the nucleus. The DNA is protected like that. And then it had the mitochondria to give energy. And then they have other kind of thing like Golgi apparatus, all these things to say, the nutrients come into the cell and the waste go out. So therefore, to keep the integrity of the cell for a well-quality long life, you need to have a propagated community. I know it's simplistic, but it is accurate. The cell wall, most of the cell wall is fat.
Mm-hmm.
And we encourage people to take a lot of omega-3, which is good. And omega-3 is very oxidizable. They're not just found in the blood. Eventually, they land in the cell wall. So if they land there, we want it to be oxidatively protected. And people talk about antioxidant until the sun comes down. So it's very confusing to the listener. And if I want to speak to the listener.
Mm-hmm.
You want to know the antioxidant that protects something that is easiest to get oxidized. And the easiest thing in the body to get oxidized is fat. I know I don't want my DNA to get oxidized. I don't want my protein to get oxidized, and I don't want my carbohydrate all correct. But the most important thing, I don't want my fat to get oxidized. If you don't believe me, you take a stick of butter, you put out on a summer day, you smell it 2 hours later, you know. Or you drive past a roadkill on a summer day, you immediately know what I'm talking about. There's usually fat that go off. Same with the human body. And in the cell membrane, the compound that intercalate, that goes into the cell membrane, that sits the best in there, like a key lock, would be a vitamin E. Not CoQ10, not lycopene, not any one of these million other antioxidants, but it's vitamin E. So I hope I capture your audience imagination. When it comes down to antioxidant, you need fat antioxidant. If you got that, then at least you got something in control and cut the noise out of the background.
Ooh,
Wow.
I do love talking about cell membranes. I gotta so yeah, like, I mean, learning that in sort of like high school biology class that the cell membrane is made of fat, and like oxidized fats, we kind of speak to that in some of the stuff that we teach at our health coaching school. There's some fats that oxidize more readily than others. And we wouldn't want that to be happening with our precious cell membranes and all the other precious structures in our bodies that are made of fat.
Mm-hmm.
So I feel like that was a really awesomely exciting and excited explanation of the role of this compound in the body. So when we talk about antioxidants, because that is a term that is thrown around a lot, to your point, Dr. Tan, like, what does it mean? Okay, what if you had to describe in the short, like a short definition to describe what an antioxidant is? Is it a thing that prevents fat from oxidizing? Is that kind of how we would say? Is that how we would describe antioxidants?
Okay, antioxidant would be this: without oxygen. It had to do with that. Without oxygen, life as we know it on this earth cannot happen.
Right.
So we cannot live without oxygen. Roughly speaking, 1 in 10,000 oxygen we consume is going to go wacko. Just think of oxygen going wacko, and scientists call it radical, oxygen radical.
Okay, yes.
But 9,999, we need it. Once you submerge in water, you know exactly what I mean. You can't stay in water for long. So we need oxygen just to live. Even in the fetus, it just goes through the placenta, a lot of oxygenation from the mother to the baby. But so we need oxygen. But 1 in 10,000, it go wacko. When the oxygen go wacko, we call it a free radical as a scientist. It go after something that is easiest to remove is very excited state. And the easiest thing for it to go after from its excited state, unfortunately, is unsaturated fat.
Mm-hmm.
Unsaturated fat have the most number of double bonds, and these double bonds are very easy to get oxidized, and the oxygen love to go after them. Now, at the same time, you two ladies are advising other people, yes, you should be taking omega-3. Fish oil is good for you. Fish oil have so much double bond. That's why they go bad so quickly, you know? So if you encourage people to take them, they must continuously take vitamin E. Otherwise, they got the good fat in, and then the good fat is not sticking around and turn bad. How can that be good? Eventually, it's no good. So for that reason alone, Laura, to answer your original question, I would have people take 100 milligrams if for no other reason is to maintain a healthy cell membrane. So our 38 trillion cells that holds a person 120 to 160 pound weight to keep the cell membrane good, just for no other reason, not any disease thing like that. So I hope that your audience is hearing this. Wow, I'm hearing this for the first time. People don't say this. They keep saying antioxidant. I know what it means. But if I were to be a non-scientific audience, I want to know. Then I said, this is all gibberish. I couldn't dig it, So right now, I hope this is useful to your listener.
It's very useful. And I think any way that health coaches can help break down what these terms mean in a way that's easy for their client to understand. Because I was asking it doesn't matter who she was, but I was talking to somebody about, she kept throwing around the term antioxidant. And I asked her if she even knew what that meant. She just kind of finally admitted she really didn't. She just knows it's good for her. She's like, I think it's some sort of vitamin. But that's because there is no explanation about what that means. This is our bodies are complicated systems, and we are surrounded by an environment where hopefully it's built to be a healthful environment. But for the vast majority of Americans, to your point, and I guess I would lump any country that it kind of falls into this westernized, industrialized kind of society, the vast majority of our environment is crap. It is literally bad for us. And we're being bombarded by things that could likely oxidize these important aspects of our body, fat in particular, because there's, So I thank you for that explanation, because I think it does help. And by the way, people, that, we teach this stuff in our course. We teach what oxidation means, and we teach the process that happens and what antioxidants do. We do teach it, but not all courses do. But that was a great explanation on kind of how to explain things, oxygen going wacko, and kind of how to fix that.
Let me tell you about my friend Carolyn. She's an athlete with a passion for health. She'd been health coaching friends, families, strangers, not even knowing it was a thing. She just felt called to help other people live their healthiest lives. Then she discovered the Primal Health Coach certification program, and she went from feeling like an imposter to belonging to an amazing community of like-minded health pros. Confident and finally able to enjoy a fulfilling and profitable career doing exactly what she loves. Carolyn is one of thousands of certified primal health coaches living their best lives and helping their clients do the same. The Primal Health Coach Institute offers a variety of health and fitness certifications and specializations. Our graduates are practicing unique coaching specialties and changing lives in countries all over the world. We're always growing and evolving, so come grow with us. Visit primalhealthcoach.com to check out our courses and offerings.
We addressed kind of what vitamin E is and kind of what it does and the rationale for supplementing with it. I especially given our environment today. So now can we get into kind of how these two types of vitamin E are different, and do they serve different purposes? Do they play certain roles? Are they commonly found together and you have to extract them, or are they typically found in different places?
They are found in different places, in different ratios. And for the Annatto, which I showed you the plant before, it is unique. It only contains a tocotrienol free of tocopherol. For me, that was just like a light bulb that just lit up, because I've never found it. And I study tocotrienol in all kinds of plants all the time. I never found it. And I think in the Annatto plant, they make these two most potent vitamin E to protect the keratin from degradation. That's it's just purely. And so sometimes I also tell people, I know it's good to eat healthy and eat a lot of plants, things like that. I think sometimes we also get funny in our head. we got the idea that a plant makes good things for people. Plant never make good things for people. Plant make good things for themselves, So
Right.
we are we're all whacked out even in our thinking like that. Plant does not make phytonutrient for human being or animal. It just because they can't move, you understand?
Right.
So they must have things, they must make toxin. So if you eat them, you die, like that. So yeah, well, how about that? You die, So plant always not always make things that are actually good for people either. But they will make things, and then they make things that are hallucinogenic. You can go there with mushroom. So I think studying a plant is a beautiful thing, and many medicinal drugs come from the study of plant. And another time you can just interview me. I can tell you story after story how pharmaceutical company, they got ideas from plant, never give credit to plant, and the poor plant can speak back. It's not like human being. I oppose. Like they just stood there, and then they go out on their merry way like that. But sometime we got lucky, then we discover something that is useful.
Mhm.
Now, vitamin E. Vitamin E look like a tadpole. Just think of a tadpole with a wiggly tail or a sperm. Just think of it like that, the picture. And it kind of look like that. The molecule of vitamin E will look like this, see?
Wow.
The head here,
Mm.
Yeah.
and then the long tail here. If I go far back, it look like a sperm or look like a tadpole. The antioxidant is here. You got to have a ring like this, and then the oxygen group, the antioxidant. This tail here, it sticks into the cell membrane, so it's like an anchor.
Yeah.
If this were to be a tocopherol, the tail would be about 30% longer. So it sticks into the membrane, and it still moves around, but it anchors deeper, slower. Just think of the cell wall, the membrane, like it go like this.
Mm.
A tocotrienol tail is shorter. See that? There's a double bond one, and then two, and then there's three here, and hence the word tri. Tri means three double bond. So those three double bond make it shorter. It spins around this thing 50 times faster. So therefore, I like to give the picture that is a local policeman who captured the radical bad guys in the town. A policeman or policewoman does not cross to another town. A tocotrienol would be like a state trooper. I know in Canada you don't call them state trooper. We have a state trooper, and the state trooper will cross the entire state. So they comb a larger surface area. So all that to say, a tocotrienol tocopherol, they do the same thing, except a tocotrienol, because they fly around much faster, they capture the oxygen radical much faster. So that to prevent it from going after the omega-3 fat that I mentioned earlier, for example. That's it. So I just explained that to you. Shorter tail, tocotrienol anchors less deeply. Tocopherol, longer tail, anchors deeply and move around much slower. So that's it. And that is true. That is done at UC Berkeley 1975. But people, you have to go into literature to read. So I did. And I gave it to you. If you don't believe me, you send me an email. I gave you the paper and you can read it. But if you want a shorthand, I just gave you the shorthand.
No, but what a great picture though, right? So the police officers, whether it's a local capper or a state trooper, or what they do the same function.
Yeah.
They just kind of one covers a greater area. It can move around a little bit faster. It might have the ability, a larger jurisdiction, so to speak.
Yeah.
So that's a great analogy. Thank you.
I do like analogies like that and descriptions that are very plain language. People can get it. And that was awesome. So I'm sold. I'm definitely on team tocotrienol now. I didn't have a preferred vitamin E before, but now I do. So 100 milligrams is in your mind the sort of effective dose.
Mm-hmm.
We're maybe getting 2 to 3 milligrams in American diets. So we're supplementing. Let's assume that we are. Let's assume we're getting our 100 milligrams of tocotrienol. What changes? Like what improvements? So I know we're getting this antioxidant benefit inside the body, but what's the symptomatology of maybe insufficiency and then sufficiency?
Currently, there's only one paper that is published. I know you're not even asking that question. uh, people until vitamin E was discovered 100 years ago, and they cannot document women to have spontaneous abortion when they did not have enough vitamin E. They were able to find some marginal, very poor Bangladeshi women, and then they have very high spontaneous abortion, and they found out that their level of vitamin E in the blood was really low. So that was a signaling. But most American is thinking of antioxidant, nothing thinking about giving birth. In a prenatal, you'll find vitamin E as alpha tocopherol. That would be the only exception I support. Outside that, I think people need tocotrienol for oxidative protection. Outside that, I wanted to say that so I won't get accused of, said Dr. Tan, you stop talking about this prenatal thing. I now in full disclosure like that. With that exception, I think the best antioxidant people can take a tocotrienol. What can you find? We have only done one study on this, Aaron, and the study we did was about 60, 65-year-old people. This kind of like beginning elderly people, they are not otherwise sick. They don't have metabolic syndrome, don't have diabetes, don't have anything like that. They're just that age, like that. So we decided to study them. We gave them about 125 milligram, I think. Not a lot, 125 milligram, about 100 milligram. So, and then because there are no symptoms, so what do we study? It's funny, right? If you're not sick, then what do you look for? I don't know what to. So we decided, hey, maybe we can look for markers of stress. It looked like from both of these two that you two ladies talk about, stress life is important. So I said, all right, I'll look at C-reactive protein. So I look at C-reactive protein, and then I look at I think C-reactive protein was the main one. One or two. Oh, oxidized fat. Thank you very much. I remember that. Oxidized fat in the body. And I noticed that the oxidized fat and C-reactive protein drop about 20%. So, but that is not something you know. You have to go to ask a doctor to do a blood work to find out. Still, it's a very simplistic thing. So we saw that. Encouraged by that, and based on probably hundreds of animal studies, we found that consistently tocotrienol work in the animal on chronic conditions of prediabetes, diabetes, dyslipidemia, and then finally, we did all kinds of clinical studies like that. Finally, we decided to do fatty liver disease. So now we have about 20 clinical trials. Rather than me blurping all of them, you tell me what you want me to cover, and I tell you what the study was, how much we gave to them, and what did we look for to prove that they are good. So I'll leave you to ask me, or I can, if you want me, I can generally summarize them also.
Well, I mean, I'm not sure if summarizing studies is maybe the way I wanted to go here. I'm more interested in like mechanism of action. So
Okay.
Personally, I really geek out on prediabetes and type 2 diabetes because that's sort of the area that I play in. I was pre-diabetic 15 years ago, not anymore. I did not tap any vitamin E to solve that problem. But if I had known it was some kind of magical liniment that could have, I'm always very curious of mechanism of action. I feel like I understand insulin resistance, but I don't understand it from the perspective of the way you do what you've studied. So can you explain maybe that piece of it?
Yeah. I follow you, Aaron. If you were to ask me this question 30 years ago, I would struggle more. Right now, if I were to be a clinician, I'm not. If I were to be a clinician, I always look for phenomenology, which means that does it work or does it not work? I know it's very pragmatic. If I were to be a scientist, I always will ask, what is the mechanism of action? So I'm always struggling with that too. As I get older, I don't know how long I'll be sticking around. So I wanted to see, does it work or does it not work on people? Right. But when I always ask for mechanism, but luckily for tocotrienol, we have both. On the issue, because you mentioned that, otherwise I can go in other directions also, because you mentioned that you were pre-diabetic, you're no more. The pre-diabetic type situation came from the concept of metabolic syndrome. And metabolic syndrome came from initially from Stanford endocrinologist. His name is Gerald Reaven, Gerald, I think, Reave, and he had retired and passed away like that. He was getting an award in the American Diabetes Association. I was a young scientist then, and he was quite impatient because he wanted to get his flight back to California. I don't know where we were, but like that. So I kind of stopped him because there was a whole bunch of people talking to him after he gave his plenary lectures. I can't get in. I'm too short and people can't even see me walking there. So I watch carefully until he leaves the stage, and then I go after him because nobody was following him. And then he doesn't like it there, you see, because he's trying to catch his plane. So, and I remember he told me this. He said, I give you one line, you go figure it out. He said, I'll tell you what he told me and then I can simplify. Hypertriglyceridemia always precedes hyperglycemia. So therefore, high triglyceride always precedes high sugar. I'm trying to tell you the mechanism he told me. This is for Syndrome X. This is when we were famous in the TV series of the X-File, But he figured out what the X is, so now we call it metabolic syndrome. No more X. It is clear now, like that. So therefore, before somebody have high sugar and become diabetic, the floodgate is contained by having the triglyceride go up. Eventually, the triglyceride is so high, it cannot handle it. So the floodgate would open and then you become a diabetic. So therefore, a pre-diabetic would have normal high sugar, but high triglyceride like that. So if you were to check your blood work periodically, just ask a physician, do a lipid profile, and usually the doctor want to know if your cholesterol is high, you don't have arteriosclerosis, but the lipid profile always have triglyceride. And usually the doctor don't read that number. But an endocrinologist always read that number because an endocrinologist care if you are diabetic or not. So they read the number. However, if you are diabetic, you're not. If a person is diabetic, the sugar is high, the triglyceride is also high. It never goes away high like that. So it was, by the way, those studies that we did, we used, you said not to ask, but I cannot not say this because the audience want to know, So we did the study and people were using anywhere from 200 to 300 milligram to mitigate the condition of high triglyceride and high sugar. And the sugar and triglyceride typically drop about 15 to 25%. Nothing to sneeze at. If you take drug, they drop even lower.
Yeah.
It was because of that, Aaron. So I'm actually doing this for the benefit of science. I am not interested to sell something to people and then it doesn't work. That's a terrible legacy of me. I'm going to retire not too long from now. So in the last 8 years, after we cluster and know about all these things, I decided that behind metabolic syndrome and diabetes and type 2 diabetes, the audience know about, is this emerging and probably endemic situation of non-alcohol fatty liver disease. It really is a terrible subset. 25 to 30%, it's 90 million people. Whoever your coaches are, whoever they're helping, then 1 in 4 or if not 1 in 3 of the people have fatty liver. How do they know? Just ask their doctor to do a blood work check on their triglyceride. Very easy, like that. And they don't usually do a biopsy unless they suspect they have cirrhosis or hepatitis C or liver cancer because it's too invasive. So they do those. So in the last 8 years, we did this. So now I'm already segue. I know you're not planning to ask me. We did a 3-month study of people with fatty liver. We gave them 600 milligrams because why do we give so high dose? Because the liver is the single largest organ. So we did 3-month study. We did a 6-month study. And finally, we finished up with a 12-month study. All these 3 papers were already published, so I can now declare it. In the 3-month study, I did not know if it worked. If my science director is here, and she will probably have more consonant in questions like you have. She already noticed something. And then said, Barrie, look at this. They said, no, Anne, I am not going to go there. So I'll tell you what it is, but I said, no, I can't go there. And I can't go there. So, but we study the liver enzyme, ALT, AST, very common. They drop. So I was encouraged. The small study published. Then the second study, I told Anne, how do we do the second study for 6 months? I need it to be sustainable because the organ is very big, So she said that, how about we study steatosis, the fat in the liver. And then you can use ultrasound like you see a baby like that. You can see the fat there. So we did that. And then we study inflammation. But we like to study inflammation that is in the liver. And most people study C-reactive protein, but most people don't know. C-reactive protein is a stress protein that came from the liver. See, most people study in the blood, but it came from the liver. So then, okay, I'm studying the liver. This is great. So we did. And then in the 6-month study, the C-reactive protein dropped. And then the steatosis, so steatosis just means fat in the liver, also dropped. And then Anne nudged me again. He said, Barrie, did you see that? That thing happened again. Then I said, so now I have to pay attention because my director is telling me it's statistically significant, but I'm uncomfortable making the statement. Then I said, and I'll tell you this. And how about we do a 12-month study? And after this, I got to stop because 12 months is a long time like that. So we did the 12-month study. So now we did all the things I told you we measure. In addition, we had CAT scan because I'm uncomfortable poking at doing a biopsy. A CAT scan, you can see more. All of this happened, and the CAT can show reduced steatosis and reduced fibrosis. If the fat stick around in the liver too long, you have scarring tissue, and scarring tissue of the liver is considered irreversible. And then we saw reversal of it. I was very encouraged. And Anne, of course, now Anne didn't have to tell me. I saw the darn thing that Anne told me, and it was still sticking, and then it still worked. And that is, these 3, 6, and 12-month patients on fatty liver, they're otherwise overweight, they lost weight. I was very uncomfortable talking about losing weight because I hear enough podcasts on the show to know whenever, and it's usually women, and then they lose weight, and they usually expect to lose 10, 20, 30 pounds. It's a lot of reality shows in 2 to 4 weeks. And I can't say that because our first study is in 3 months. She said, well, then she said, yes, you cannot say that, but you can say that they lost weight in 3, 6, and 12 months, and the weight loss is sustained, approximately 5%, about 12 to 15 pounds.
Wow.
I think that the weight loss is not because they are weight loss. The weight loss is because the metabolic process is coming back into balance. The stress is reduced and the body is coming back in swing. And then the body is not stressed to contain with weight and the weight loss. And we believe that most of the weight loss is because of fat. I am actually thrilled about that. And because of that, we are now doing a study in Texas. If I don't own my company, my boss will fire me because I do all this study. It costs a lot of money and a lot of time. So in Texas, we have an obesity study now. This time, we're able to get fat biopsies. And so they're obese. They're not overweight. And obese people carry a lot of, this is no judgment. Simply doing the work to find answers like that. And then we gave them a 300 milligram tocotrienol. If it manages their weight, if it manages their severe inflammation, then we have a strong case of this kind of vitamin E tocotrienol. They are properties unshared by tocopherol. So Aaron, if you ever go to the store to buy tocotrienol, please don't buy tocopherol. They are cheaper, but they don't do what I am telling you that tocotrienol vitamin E can do. So thank you for allowing me to share that.
No, but
great.
So I'm trying to kind of break this down in terms of sort of health coaches being able. So if you see from metabolic, any health coach that graduates from our program understands kind of metabolic syndrome, what that means and what some of the markers are and all of these things. So everything you were talking about, I think is familiar, at least for folks that graduate from our program. But in terms of like high levels of blood sugar, a precursor to that often being high levels of triglycerides. And you were saying that this acts actually as a way to sort of protect these fatty acids, right? To keep these fats from oxidizing. So is this kind of what's happening, that this vitamin E is sort of keeping that excess fat in the body from oxidizing, thus lowering inflammation, broadly speaking, that then allows the body to, this is what we're trying to kind of tease out here based on your study, is what is the role of toco?
Just call it Toco. Just call it Toco.
Okay. So is it this high level of triglycerides, these fatty acids that are so unstable, I guess, or prone to oxidation, and we but we provide this vitamin E, this toco, in order to reduce the damage done to these triglycerides and lowering inflammation, broadly speaking.
We did find that because we measure oxidized fat. I forgot to tell you this. That's a great question, Laura. And we measure the oxidized fat, and the oxidized fat in the blood for those on tocotrienol was lowered. Also about 25-30%. So we knew that in animal study like that. We will not know directly from the fat tissue until the study in Texas on the obese people are done, because we have biopsies. So we are anxiously following that. But we are doing something even mechanistically more directing to what Erin is saying. So what is the mechanism? She keep asking like that. When you have severe inflammation, until about 10-15 years ago, we just thought that the fat is a blob. Right. It's just a momentum there, and they just don't look good. We just want it to be out there, but it is not so. Fat is actually metabolically active. Right. If you look under leptin and adiponectin, these are very inflammatory cell signaling. They reside in the fat. So when people carry a lot of fat, this kind of cytokine is very reactive and cause severe inflammation. Gotcha. We cannot do those studies until we get the fat tissue. We will have that in the obesity study. But in the fatty liver study, we clearly measure the fat in the blood, and the oxidation of the fatty acid in the blood was decreased. And that is for no other reason other than the tocotrienol is preventing oxidation of the fat.
Awesome. Thank you for that. That kind of wrapped it all up in a bow. So I know that we have kind of a hard stop here. So we want to give you an opportunity to say, so at the end of the day, you've done all this research, you've written a book about it, right?
Yeah.
And you've developed a supplement as well, right? That sort of isolates the...
Yeah. I would say, if your audience want to download a copy of the book I described, you can download it free of charge. And you can go on barrietan.com/book, and then you'll be able to download a copy. If you go to our company's website, American River Nutrition, or you type my name, or you type tocotrienol, it's going to lead you to the same place. So, but American River Nutrition, you can download all the white papers that I wrote, even more detail about a clinical study on tocotrienol, like that. They'll come to a place you can buying the supplement. We don't sell finished product. Our customers, our clients are company. They're not individuals. So there we don't sell finished product. We only provide the study, the published work that companies probably would not have the time of day or money to spend on. They will list all the compound, but for a shorthand, I would trust to, and you can find in Canada and in the US, you can buy online. They're called Designs for Health. If you go to the designs, that's in plural, Designs for Health, and they'll have it. For people who take it as an antioxidant protection, otherwise no other condition, about 100 to 150 milligram would suffice. For people who have mild chronic conditions, such as what we study with prediabetes or diabetes, probably 200 to 300 milligram would work because body weight. And then for people with severe conditions, some of them I mentioned, then it's probably 400 to 600 milligram. Now, I know you two have not asked me, but I did it purely not for the love of it, for the indication of it. There are 500 to 1,000 animal studies on tocotrienol. Unlike anything else, they kill the cancer. They systematically kill the cancer. If you don't believe me, Google tocotrienol and cancer, and particularly type delta tocotrienol, like Delta Airline, and gamma tocotrienol. And these are the only two compounds found in Annatto. only two.
Yeah.
And they're the most potent, and you'll find it. So therefore, about 8 years ago, I decided if that were to be so, I want to do clinical study. So currently, maybe another time if you go to my website or the book, I describe it.
Yeah.
In
Great.
Denmark, we done 4 clinical study. If I were to be a woman, I'm taking closely attention to this. We study ovarian cancer, breast cancer for obvious reason, and then both men and women, colon cancer and lung cancer because of smoker, and all done in Denmark. And then the 5th one is in pancreatic cancer in Florida, and it's done in University of Southern Florida in Tampa. And right now we know pancreatic cancer work and ovarian cancer work. We are still waiting answer for the other 3 cancer from Denmark. So there you have it. I know I cannot say it in the bottle, so I still go back to the metabolic syndrome part. But the audience are smart. You can go online and read. So even though we just list the paper, never can say on the bottle, I'm fine. If the studies say so, then the studies say so. We probably will never get the FDA to approve anything with the big C word. But the big C word is the one that brings dread to people. So I decided to work on the study. I know our time is up.
Yes.
It's great talking to you too. Hopefully one of these days I can run into you too and say hello like that.
I hope so. Thank you so much. This was really I learned a lot. So thank you very much.
Really great stuff. Thank you, Dr. Tan.
Thank you.
This podcast was brought to you by Primal Health Coach Institute. To learn more about how to become a successful health coach, get in touch with us by visiting primalhealthcoach.com/call. Or if you're already a successful health coach, practitioner, influencer, or thought leader with a thriving business and an interesting story, we'd love to hear from you. Connect with us at hello@primalhealthcoach.com and let us know why we need to interview you for Health Coach Radio. Thanks for listening.